The ACORN project brings together 3 research organisations with 4 European SMEs to develop new coatings designed to increase the lifetime of both static and moving components of offshore wave and tidal devices. For renewable energy to viably compete with fossil fuels, offshore devices must be able to provide power for decades without degradation by the harsh marine environment. Any static component moored for long periods of time offshore is liable to damage from the surroundings. The highly corrosive saltwater environment attacks structural components, and organisms such as barnacles can settle on the surface and destroy protective paints that have been applied. Hard fouling organisms like barnacles can also decrease the hydrodynamic efficiency by creating increased drag forces on these devices. The ACORN project aims to develop a new coating technique that will provide long-term resistance to both seawater corrosion and marine biofouling. Corrosion resistance will be imparted to the component using thermally sprayed aluminium, a well-established method routinely used for offshore corrosion protection in the oil and gas industry. During spraying, a jet of molten aluminium particles is projected at the substrate to build up a thin coating. This aluminium layer prevents the underlying steel from corroding, even if small regions of the coating are damaged and exposed to the seawater. This corrosion-resistant coating will be combined with novel bioactive compounds which prevent barnacles from settling on the surface. Used in very low concentrations, these compounds prevent biofouling without releasing high levels of biocides that can cause damage to the surrounding marine ecosystem. These active components provide extremely effective resistance to barnacle growth and have the potential to help prevent corrosion and reduce drag forces associated with large-scale marine growth. Moving components of wave and tidal devices, such as blades and turbines, can be subject to damage by the seawater through a different mechanism known as cavitation. Cavitation occurs when rapid changes in local fluid velocity cause pressure changes, which result in the formation of bubbles. These bubbles then collapse against a surface and create a shock wave. Repeated impact of these shock waves result in erosion of the surface and degradation of the moving component. The ACORN project will develop and test hard-wearing cavitation-resistant coatings that are also resistant to seawater corrosion to prevent moving turbine parts from cavitation damage. If you would like to find out more about the ACORN project, please visit our website at acorn-project.eu.